All right, I think that's enough talking about the technical aspects of your system design interview. Just as important is strategies for actually getting through the interview itself. A lot of what they're looking for is not your technical expertise, but just how you approach problems in general and how you work with others. That is equally important to the technology that you're invoking. So let's spend a lot of time just talking about strategies for getting through the interview itself successfully. These are more about soft skills and how you approach problems in the actual technologies themselves. And I can tell you, as a interviewer at Amazon, where I did thousands of these interviews, this is what I'm looking for more than anything else, really. Like, I want you to come up with a solution that makes sense, but it's less important to me that you actually finish and get a fully fledged system that actually scales. It's more about, can you take feedback from me? How do you respond to my direction? How do you work well with me? How do you think? How do you approach problems, right? So let's start with that. So usually in a system design interview question, you're going to be given some incredibly vague problem to solve. And that is intentional because the interviewer wants you to break that down and clarify the requirements of what you're asking them to build. So I might give you some incredibly, high level thing like, I'd like you to design YouTube for me, or design Google search, please. And some people will just sit there and kind of look like the deer in the headlights and, quietly cry to themselves a little bit. They don't really, but at least I hope not. But the successful interviewers will say, okay, let's break that down and see what you really want me to do. So the first step is to turn this really vague direction they've given you into concrete requirements. So first of all, you should always start by repeating the question. That's sort of a basic communication skill. If someone's asking you to do something, just repeat it back to them and make sure that you understand it properly. So if I say, design YouTube, first thing you should say, okay, you want me to design YouTube, the big video streaming service. And just make sure you're on the same page. After that, it's time to ask lots of questions. Break that down into what they really want you to build, what the requirements for it are, and just think out loud. As you're approaching a problem, don't just sit there in silence. That's not doing you any good. Let your interviewer see your thought process. So as you're thinking about different strategies and the pros and cons of them, don't keep it inside your head where the interviewer can't see it. Talk about it as you're thinking through it. And that will also give the interviewer a chance to steer you in the right direction, which is only going to help you, okay? Now, we're going to see this practice in our mock interviews a lot, but just at a high level, you should start by repeating the question and then break it down into specific requirements, right? So if I say design YouTube, you should say, okay, you want me to design YouTube? What parts of YouTube do you want me to design? Obviously, there's a lot of things to YouTube like recommendations and editing content and channels and advertisements and managing payments to people. What piece do you want me to focus on? Is it just the storing and the serving of the videos themselves? Odds are they'll say, yeah, let's just focus on that because obviously you're not going to design all of YouTube in 20 minutes. So narrow it down, first of all, to what they really want you to do. And once you get to that point, okay, you've broken that down to just the problem of storing and vending video data at massive scale. Ask, more clarifying questions like, how much video are we talking about? How much traffic are we talking about? And they might push back on you and say, well, what do you think it is? Where you might have to estimate that yourself. That's fine. But just make sure you come to an agreement about what the scale of the problem really is, what the requirements are in terms of latencies or availability that you need to think about. That will inform what kind of trade-offs you can make in your design. Budget as well. Do I have infinite money and infinite servers to throw at this, or do I have cost constraints to think about as well? So clarify those requirements up front. And as you start to think about what the implications of those requirements are, talk about it. I've seen one other system design interview prep course, and his advice was to start off by saying, okay, can I think about this for 5 minutes? And, I think that's a terrible idea. Don't just sit there in silence for 5 minutes. A, it's awkward. And B, the interviewer doesn't get any insight into your thought process, which is what they really want to see. So no, do not just sit there in silence for 5 minutes while you think about it. Think out loud. Let the interviewer see your thought process. Now, as you're approaching a technical solution, and once you understand what those requirements are, a good idea is to work backwards. What does that mean? Working backwards from the customer experience. So it's very tempting to start with your favorite technology and say, oh, okay, I want to use Apache Spark or deep neural network for this problem, and work forwards from your favorite technology and hope that you end up with a solution that meets the customer requirements. A better approach is to work backwards from those customer requirements and figure out what technologies meet those requirements. Okay, so that's working backwards. For example, YouTube. Okay, I need to vend massive amounts of videos all around the world at very low latency and at massive scale. Well, that probably means I need to use a CDN for my most popular videos at least. Where does the data come from that feeds that CDN? How is that data, cataloged? How do I access it? You work backward from the end user to the CDN, to the distributed data store that feeds that CDN, to the systems that populate that data store, right? So that's working backwards as opposed to working forwards from the lowest level technology and hoping you arrive at the right end game. Now, this will gain you major points at Amazon because working backwards is a very core piece of their entire culture there. You are, routinely expected and evaluated on how well you do that at Amazon. So working backwards and explicitly say, okay, I'm going to work backwards from the customer experience here. My gosh, that will get you so many free points at an Amazon system design interview. I'm not even kidding. And it's still, even at places other than Amazon, the right way to do it. And I think most interviewers will appreciate that. So, tying it back to that YouTube example again, start off by asking clarifying questions. How will users discover the videos? Do we need to think about building a search engine or a recommender engine or an advertising engine? So first of all, figure out what the customer experience is that you're being asked to deliver. What piece of it are you being asked to design here? Because obviously it's not all of those things, right? So you can use those questions to limit the scope of what you're being asked to do, which is going to make your life a whole lot easier. So start by understanding what customer experience you're being asked to deliver, and then work backwards from that customer experience to the technical components that you need to deliver it. Talking some more about that. So start by identifying who are the customers. Are these people all around the world? Are they in one specific region primarily? What times are they, are they accessing your data at like weird times? Are there weird peaks in traffic that we need to worry about? What are their use cases? What are they trying to do? Right? So within the confines of what you negotiated for what customer experience you're focusing on, they're trying to find a video and play it back, in a reliable manner. They don't want to see any buffering, right? And which use cases do you need to concern yourself with? So again, don't paint yourself into a corner where you're trying to design all of YouTube in 20 minutes or all of Google or all of Amazon. Make sure you define upfront what piece of it they really want you to do. So your first task in any system design interview, I'm just going to keep hammering this home, clarify the requirements of what you're being asked to design, all right? And do that in terms of the customer experience whenever possible. Your interviewer is really trying to see that you can think about problems from a business perspective and not just a technical perspective. So if you start with the customer experience and focus on that, that shows me that you can think about this like a business. You're not just thinking about the technology, you're thinking about how this technology will provide an experience to this company's customers that can make them money down the road, right? That's what we're all here for in a company. It's not just about, being cool and applying cool technology. It's about finding solutions for delivering new customer experiences that customers find compelling. So once I've defined the customer experience I'm trying to deliver, what do we ask about next? Well, probably we're going to want to define the scaling requirements of the system I'm being asked to deliver, right? So nail down what the scale of the system is really. Are we talking about hundreds of users or millions of users? That's going to make a big difference as to what sort of technologies I invoke. And that will inform you on the need for horizontal partitioning. So if the scale is massive, then we know we need some sort of horizontally scaled solution. We can't just throw one giant database at it or one giant web server. We need some sort of distributed system. And if it's truly massive, maybe we need to rely on cloud storage solutions like S3 where somebody else is managing all that cost and complexity for us. Also, understand how often the users are coming. What kind of transaction rates are we talking about here that we need to support? Again, if it's large rates of transactions, and you're going to need a large number of servers at the front end to manage those transactions. And maybe you need to think about how those transactions are distributed across different data centers and across the world. Also define the scale of the data. Okay, so that data has to come from somewhere. It probably needs to be processed in some way. Are we talking about hundreds of videos or millions of videos, billions of videos? If so, if it's a really big number, then we need some sort of distributed system for processing that data and storing it as well. And, for YouTube, obviously, those are all going to be very, very large numbers, millions of users, millions of videos, maybe even billions, I think, these days. And you're going to need to employ every trick in the book for horizontally scaling your servers and your data storage and your data processing. But, not every problem warrants that sort of an approach. If you're being asked to design some internal tool that's only being used by, some department within your company, maybe you don't need that level of complexity and expense. You should always prefer the simplest solution that will meet the requirements. But generally speaking, if you're being asked to do a system design in a large company, the odds are good they're asking you to design something at massive scale. So more often than not, the answer will be some sort of horizontally scaled solution. But, you should think about it. At least articulate that, hey, this is massive scale. I need to do horizontal scaling. So in the off chance that you're being asked to design something smaller, go for simplicity, and explicitly say that's what you're doing. Say, hey, I know we could throw, a big Hadoop cluster at this problem or some big distributed Elasticsearch cluster, whatever it is, but I don't need to. I don't want to have to maintain all those servers if I don't need to, and I don't want to be paying a big web services bill either. So why take on that complexity where I can just have a database and a backup database and a few web servers in front of it and be done with it, right? So just, again, think out loud. And if you're going in the wrong direction, that gives the interviewer a chance to steer you in the direction that he wants or she wants. Also, define your latency requirements. How quickly do you need to return these values? How fast is enough? So that might tell you about the need for caching and CDN usage, right? So if it's the case that these videos need to be played back with very low latency and you really can't tolerate any buffering at all, then you're probably going to need a CDN. But if your requirements there are a little bit more forgiving, maybe I don't need a CDN. Maybe I can do without caching. Remember too, caching isn't just about latency and speed, although it does give you that because you're avoiding disk hits. It also reduces the load on the underlying services and data stores that your cache is in front of. So it's also a tool for scaling. So caching is not just for handling very strict latency requirements. It can also save you money on actual equipment too. And if you can, try to express this in the language of SLAs, the percentiles we talked about. So, say we're shooting for 100 milliseconds at 3 nines, that just shows that you can speak their language, right? Although those specific numbers aren't going to mean a whole lot in the high-level system design that you're going to give them. I can't design a system on the whiteboard that will specifically give you, 57 milliseconds at 3 nines, but I can design a system that I think is reasonably capable of doing that, right? Again, for the example of YouTube, do I need to cache their recommendations for videos? Do I need to cache the video metadata and video descriptions so I can very quickly return that page? So latency might refer to page latency, the actual time it takes to render a web page to the end user. If they want to get that page rendered in under a second, for example, that means I need to have very fast access to all the information being displayed on that page. And that probably means some sort of local caching of information like the video descriptions and where that video was stored and streamed from. Also, define your availability requirements. How much downtime can you tolerate? Is being down a threat to the business for this system, or is it just an inconvenience? That can inform you as to how much money you want to throw at redundancy here. Now, if they're saying, yeah, this is a mission critical system, it cannot go down, then you need to design for high availability. So that means that as you're going through your system design, you want to talk about redundancy being spread out across multiple racks, multiple regions, multiple data centers, as opposed to just designing for simplicity or frugality where you have a minimal number of servers and a minimal number of locations. Also, if you're designing for high availability, make sure you're looking out for single points of failure, and you can speak to how those are going to be managed as well. If your master node goes down, do I have 2 more ready to take its place on a moment's notice? Will that happen automatically? Those are all going to be important things to talk about if you've been explicitly told that this is a high availability service. And they might not tell you, right? Sometimes they might expect you to arrive at these answers yourself. And again, if you just work backwards from the customer experience, that can inform you as to what the optimal customer experience might look like. So if they don't tell you what the latency requirements are, say, well, as a customer, I expect pages to render pretty quickly. I would expect, this web page to render in under 1 second. That means I need to have very fast access to this data locally available, probably in a CDN somewhere. If they don't tell you what the availability requirements are, think like an owner. This is again an opportunity to demonstrate that you can think from a business standpoint as opposed to just a technical standpoint. Think, well, okay, how crucial is this to the business? What happens if the system goes down? Does it mean that my customers are unhappy and they might go away? Does it mean that I can't serve ads and it impacts my ad revenue? Does it mean that I can't handle orders anymore? If so, then yeah, this has to be highly available. And we're going to have to think about redundancy and resiliency in our design. Sometimes you'll have to do some back of the envelope calculations. Sometimes interviewers like to do these sort of higher level questions, and they make you think about, okay, well, how many videos does YouTube actually serve every second? And I think those sorts of questions are going out of style a little bit because, people are starting to realize they're not really that helpful. But, just be ready to do that sort of calculation. Make an educated guess of how many users does YouTube really have. It's probably in the billions. How many videos do they view during a given day? I don't know, 2 or 3. From there, you can arrive at, a rough estimate of how many videos per hour, per second, whatever it is YouTube needs to serve. And, before you proceed to actually design the system, make sure you're getting buy-in from your interviewer as to what these requirements are. So don't just throw out these numbers and say, okay, that's the right answer. At least get them to nod their head at you and give you some acknowledgement that you're on the same page as to the requirements for this system. You don't want to start designing a system given the wrong set of requirements. So make sure you agree explicitly on what those requirements are upfront. All right, I've said this before, but I'm going to say it again. Think out loud during your interview. Don't just clam up for 10 minutes while you think about things. For all you know, you only have 15 minutes for this question, and you don't want to spend 10 minutes of it just sitting there in silence where your interviewer has to just wonder what you're thinking. Do not do that. Think out loud. Use that time to clarify requirements. Define the constraints of what you need to build, and then think out loud about the high-level solutions you're considering to meet those requirements. Say what you're thinking. Okay, well, I think we need a CDN, and maybe we need to use Apache Spark to process the data down here, and maybe Kinesis to stream stuff over here, and maybe a DynamoDB over here to store that data. Just talk and think. Let the interviewer see how you're approaching this problem from a technical standpoint. And that's important because it gives the interviewer not only a chance to see how you think, but also to steer you in the right direction and see how you respond to that guidance, right? Part of what they're trying to evaluate here is what it will be like to work with you every freaking day. So work with them. Show that you can work with them. Think out loud. Let them work collaboratively with you. Show that you can take feedback. Show that you can modify your design in response to that feedback and not get all defensive about it. That's going to be a much better use of that 10 minutes than just sitting there in silence. Again, you don't know how much time this interview is going to have. Very often, it's only going to be about 20 minutes for this entire problem. And if you spend half of it just sitting there in silence, you've wasted that time. You've wasted that opportunity to show your interviewer how you think. So once you've got some high-level components, start sketching out your design. Maybe this is on a whiteboard if we're back to in-person interviews, or maybe you're doing it on some collaborative thing or sketch pad over the web. But sketch out your high-level design, and it can change, right? These are just your initial thoughts. Again, think out loud. Even if it's not perfect yet, get something on the board because you don't know if you're going to run out of time. You want to have something up there, right? Start with the high-level components. Okay, I've got clients out there on the web. I've got a fleet of web servers, got a fleet of recommendation servers. Maybe I have some, as you can see, this is sort of an architecture for actually vending recommendations on Amazon, which is another interesting design problem I used to use. But you can see here that I'm not actually going into the details of how this is distributed. I'm not going into the details of how the load balancers work or how these service fleets are distributed. I'm just drawing big old boxes that refer to these high-level components because I want to make sure I have at least something on the board that works before I run out of time. Okay. So in this example here, again, we start with the clients. Again, work backwards, start at the top here if you can. Those clients are going to be hitting web servers through the internet. Those web servers will need to talk to some sort of service suite that vends recommendations to those clients, what books they should be reading or whatever it is. To make those recommendations, it's going to need to draw on past purchase information. That purchase information will probably be cached because I don't want to be hitting the purchase database all the time for that. And it will also need to talk to some other service that tells me what items are similar to the stuff I bought in the past. And again, it's probably going to be beneficial to cache that as well. So I've just drawn in high-level components here: clients, web servers, a recommendation service fleet, a purchase service fleet that has Memcached or Redis or whatever you want, an item similarity service that has Memcached or Redis or whatever you want, and some purchase database that contains all the past purchases for everybody, which obviously would need to be cached. Again, work backwards, especially if you're at Amazon. You'd want to start at the top of this diagram, not the bottom. And then as time permits, you can flesh these out. Okay. Then if you still have time to talk about things and you've gotten some buy-in from your interviewer that, yes, this seems like a reasonable approach, you can start to dive into more details as time permits. How do these things scale? How are they distributed for availability? Am I actually going to be hosting these things across different regions? Am I going to have a CDN in there someplace? Or am I thinking about racks and data centers and redundancy across them? Are there any single points of failure here? What is that purchase database exactly? Is that just a giant relational database that's a big old single point of failure? Or is it a big distributed thing like DynamoDB or MongoDB or something? And as you're going through it, make sure you're giving the interviewer a chance to talk. Have a few breaks in your speech to let them interject and give you some guidance. And if they talk, listen to them. Usually if they're trying to talk, it's for a very specific reason. They're trying to see how you respond to a specific challenge, how you think about a problem maybe you haven't thought about yet. And they might just be trying to steer you in the right direction. They're probably trying to just help you out. So let them do that. Give them a chance to talk. And if they talk, listen to them, okay? And answer whatever question they asked you. And as time permits, identify what the bottlenecks are. If you end up with time to spare, you can talk about the maintenance of the system, the operational costs and concerns of maintaining the system and keeping it up and running reliably, things that might fail and how that failure might be handled in an automated manner. Just show that you understand the trade-offs of the choices that you're making, right? And the operational costs of managing and maintaining the system you've designed. Notation and format generally doesn't matter a whole lot. Boxes with lines is probably fine. You don't have to generally think about any formal things like UML or whatever. Just make sure you can communicate what it means to the interviewer. So even if you're using your own made-up notations here and terminology and symbols, as long as you can explain what they mean to the interviewer, you're probably okay, because really isn't a whole lot of standardization around how this works. Just make sure you communicate it, right? So I'm going to have a giant database here that says purchase DB. You probably want to be explicit that, no, I don't really mean a single database host here. I mean some distributed NoSQL solution, and we'll get into the details of what that is as time permits. Also be honest. There's nothing worse than trying to pretend that you know stuff that you don't. A good interviewer will find that out, and it won't end well. So if you say, oh yeah, I know exactly how service XYZ works, and well, that's just asking for trouble, because the interviewer is going to ask you a lot of details about that service and see if you're lying or not. So don't make stuff up. Don't pretend to know stuff that you don't know. If you're steered into a direction explicitly that you're unfamiliar with, just say so. It's better to be honest about it and say, I don't know. Don't be afraid to say, I don't know, okay? But after you say, I don't know, make an effort to know, right? Show that you're willing to work with the interviewer to understand what's being asked of you and understand some ways forward. Don't just give up, right? This is sort of a delicate area here where you always want to admit up front that you don't know something, but that doesn't mean that you're giving up. It means that you're still curious about finding a solution, and you're willing to work with the interviewer to find that solution. If I think about my first interview that I did with Amazon myself, way back a long time ago, that's what happened. They basically gave me a really hard algorithmic problem, and I basically said, I don't know. I've never dealt with anything like this before. I've never actually even dealt with e-commerce before. I came from a game development background, but I didn't give up. I talked to the interviewer to understand a way forward and a way to solve this problem together. And it was that willing to collaborate and that perseverance ultimately that got me the job. We'll talk about that some more too. A big thing that interviewers are looking for is perseverance. They want people that will not give up, because on a daily basis, you're going to be given problems that nobody has solved before. You're not going to be able to look up the solution of how to do the stuff they want you to do. And they want people that are going to have the grit and the resolve to find their own solutions and to work with others to arrive at those solutions. Okay. So if you're being asked to do something you don't know, say, I don't know, but try to ask questions to find out how to do it, and get some guidance as to how to approach the problem instead. Like I said, great opportunity to demonstrate that you have that grit and perseverance that they're looking for. Once you're done with your design, you'll have to defend it. So odds are your interviewer will dig into it and try to pick it apart. They're going to try to poke holes in your design and see how you address them. So what happens if this particular component fails? What happens if this system fails? What happens if this whole region goes down? Be prepared to speak to that. And we talked about resiliency and strategies for distributing your data and backup hosts and whatever. So have those answers in your back pocket if you didn't already talk about them. Also, what happens if we get a sudden surge of traffic or data? If I'm being asked to design a system for Amazon, what happens when it's Christmas time? How do I quickly add capacity to the system in a way that will scale smoothly? And, did you actually meet the scaling and availability requirements that you defined? Did you deliver the thing that you said you would deliver? It's one thing to say, okay, these are the requirements, but it's another thing to look at your design at the end and say, yeah, I think this could meet those requirements, and here's why. I think This will be available because I have this much redundancy in place, and I have these backup systems in place that will automatically take the place of failed hosts. And it will be fast because I've done this caching here. Does it meet all the use cases discussed? Make sure that your design is going to do everything you said it would do for the customer. At the end of the day, that's all that matters. And if you could make it better, what would you do? If you're lucky, you have a few extra minutes and you can actually use that time to refine your design further. How do you optimize it? How do you simplify it? God, I would love it if more interviewers would talk about how to simplify systems when they were done, right? Because simplicity, if you work in industry, you really start to appreciate the value of simple designs because they're much easier to maintain. And maintenance is just a huge headache. So if I look at the system and say, hey, maybe I don't need these two systems over here. Maybe one would do. Or maybe I don't need to use this system running here that I developed from scratch and I'm maintaining myself. Maybe I can use a serverless solution offered by some web service out there to do it for me, right? What is its operational burden and how can I manage that? How do I monitor this system? How will I be alerted if it breaks? What sorts of things do I want to monitor? What do I need to monitor? And who needs to be woken up in the middle of the night when something goes wrong? Can I offload that operational burden to someone else? Again, maybe if I use a serverless technology from some cloud provider, maybe I can make them worry about operations instead of me. But whatever you do, don't get defensive, right? So the interviewer is going to critique your design. They will try to find problems with it. If you get all defensive and say, no, this will all work just fine, I don't know what you're talking about, that's a big red flag. They're going to say, hey, I don't want to work with this person. They're going to get all defensive all the time and prickly, and they're not open to collaborating with others or taking feedback. That's not somebody that I want to work with on a day-to-day basis. So, if you are given feedback, it's a good idea to repeat that feedback back. Again, just basic communication skills. Don't get defensive. Just start thinking about, okay, how can I address this concern? How can we make it better? And again, if you don't know the answer, try to work collaboratively with your interviewer to come at one. This is just as much about finding out what you're like to work with as it is about how good you are at designing systems. So always remember that. Don't be a jerk.